Hey, so today I want to be talking to you about an overview of where fine tuning models is today. So, the kind of fine tuning I'll be talking about is the LoRa and the QLoRa techniques, and also a few other kind of techniques that you have accessible directly on these apps. But yes, focus more on LoRa and QLoRa. So, the first technique, the first resource I want to discuss is MLX. So Apple has a framework called MLX where they have some examples. So let me just take you into the Apple MLX examples directly. So as you can see, we're already inside the Stable Diffusion's example, but let's go one step back. MLX examples. So here, so they have a lot of examples. I'd implore you to check it out, but the one we're looking for is LoRa. So this is the one that is for training. So LoRa and QLoRa, parameter efficient fine tuning. So let's go here. So there's already an example loaded up for you to play around with where they're training a quantized Mistral model, which is 7 billion parameter model, um, with a data set I get from Wiki SQL. So I guess this data set is from HuggingFace, available on HuggingFace as well. Wiki SQL HuggingFace. So there is a little data about this this data set. So you can just look into it. But yeah, you can just run this really easily on your Mac if you're a Mac user, and you can just dive right into this. Okay, now the second thing that I want to talk to you about is AutoTune. So a lot of you might have heard about this. So a lot of you might have heard about this, but yeah, let's just look at what it is and what you can get done with it. So we'll go right into Hugging Face, and let's just go to Hugging Face and we're into models. Let's go into the model garden. Okay, here we have some models. Let's say we have Llama 3.8b and you want to fine tune Llama 3.8b for your particular task with your particular data set, either generated synthetically or non synthetically. So here you have an option called train, and you just go here. So obviously you have the Amazon and the Nvidia cloud options, but AutoTrain is the most easy without code. They This is just without code. So all you go create a new AutoTrain project. You name the space, you get the license. So I so the you'd have to go, so depending on what you require, you need a different license. So if you're trying to release this model for people to use, then you definitely need to look into this license. I definitely so there's a Llama 3 community agreement, so I'm guessing this one would be best. Now let's select the space SDK. So here we have Gradio up to 3 templates, Docker we have up to 13 templates, but I would use Streamlit, and I always use Streamlit because it's the easiest and you can use the most amount of instances. Here you can select your CPU and your GPU, or your GPU, something that you want to train on. So this is $10 per hour, and I recently saw someone that said they trained an entire Llama 70 billion model in 2.5 hours, fine tuned it on a particular data set. Let me just quickly pull that up for you. This was last evening. So here it is in my replies. Yep, this is the one. AutoTrain fine-tuned Llama 3 70B is now one of the top models on the OpenLLM dashboard. He used a 8x H 100, and it took him 2.5 hours. So look, by the looks of this, if that'll be up to like $25. So yeah, this is how this AutoTune basically works. So once you get going, so let's say we go for, okay, since ours is a smaller thing, a smaller model, we just go to this sleep after 15 minutes of inactivity, only you and personal space members private, and create space. Okay, space name, let's just call this test. Create space. Your payment information is required by Stripe. Okay, so I don't really want to do this, but it's quite easy from here. It's no code. You just pick your data set, you pick your model, and you're done. You get your license. And to get a more better understanding of these licenses, I'd ask you to look into the documentation. And yes, because each license is different for a different reason, and there's a lot of licenses. So all I can do here is tip you that, hey, look at these licenses before you get going. So AutoTune was the next thing. Okay, then I found a few options that were posted by YouTubers, specifically someone called Mervin. So Mervin is a YouTuber I've been following for a while lately, and he has two basic uh, YouTube videos for AutoTuning Jemma, AutoTune Jemma. Let's just go directly to Mervin. So this is his code for fine-tuning Jemma on giving more structured outputs. So he uses the Databricks Dolly 15K dataset to fine-tune Jemma. So if you look at Databricks Dolly 15K. So Databricks Dolly 15K dataset. So yeah, this is what your dataset basically looks like. So I'd implore you guys to start looking at datasets more and start looking at their structures and what purposes they were built for. So to kind of understand how people are trying to control these black box models, because LoRa and QLoRa seem to be pretty efficient at controlling an output because you already have a lot of data in these models, and a smaller model usually requires more fine tuning. And the more epochs you fine tune and the more data you fine tune your models on, the better they get. The loss factor just becomes lesser and lesser. So yeah, apart from this, I would like you guys to explore all of this. And people are getting fine tuning down into, like you saw with AutoTune, no code, and with MLX maybe just one script, and with Mervin another script. So this is just about a few lines of code. So I guess you guys should, it's becoming very easy to start fine tuning models. This is the same kind of pace that I saw crypto developing in a few years ago. So and where it is today is amazing. It has slowed down crypto at least today, but I don't see AI slowing down because the adaptation is for everybody. So I would really, really like you guys to dive deeper into fine tuning your own models for your own required data. The real reason that I showed you these different data sets instead of my own data today is because I really don't have that amount of data or a particular use case for this data. There are certain pros and cons to this, with the pros being that um, I can employ any kind of fine tuning technique to any kind of model. But the con is that I'm not really related to this data or the model at all. Like, it's not for my use case. So I'm never really going to learn it in a way that it's going to be really effective for me to solve a problem tomorrow. But that being said, always got to learn, always got to keep trying. In that spirit, I hope this video helps you guys and you get a good start at training models. So see you in the next one.